Welcome to the 6th video of this series, where we'll apply the material for the dress in Painter, make adjustments and export maps to use on the dress in Unreal Engine. In the designer interface, navigate to the export icon and choose the option to send your selection to Substance Painter. Once in Painter, take the material and drag it into the viewport to apply it to the mesh. This isn't looking exactly as expected at the moment because the mask switch is currently deactivated. To rectify this, go to the Material Properties and change the projection to Fill. This will cover all of the UV tiles without repetitions. Next, go into the Technical Properties group and switch the mask to Dynamic UV Mask Painter, enabling it to account for the UV shells. This will force the material to create an outline from the UV shells. You can now experiment with the parameters to get a variation of the design that you like. For example, you can change the width and roundness of the print, or invert the metalness so that the fills are metallic and the outlines are non-metallic. Having previously exposed all of these parameters in Designer allows you to edit the material non-distractively until you are perfectly happy with this look. Holding Shift and right-clicking, drag in the 3D view to rotate the light source. One more thing we haven't dealt with yet is the sheerness or transparency of the fabric. To include the opacity channel in your color map, you'll need to turn on the opacity channel, and in the Texture Set settings, select Unsupported by Shader, and then Opacity. Although a preview is not available with the current shader, activating the opacity channel display will confirm its presence. When you are satisfied with the adjustments, save your file and proceed to export your textures. Select the folder for the output and set the output template to Unreal Engine 4, the file type to PNG, and the size to 8K. This will save all 4 UV tiles for each channel. So let's set up our Unreal 5 scene from the Unreal Project browser. Go to Film, Video, and Live Event section, and select a blank template. Check Ray Tracing, give the project a name, and select the location where you want the project to be saved. Hit Create and Unreal will open a blank scene with some preset objects in the scene. Go to File and select New Level. This will give you a dialog where you can select Open World and hit Create. You will get an Open World preset that includes a pre-made landscape complete with sunlight, sky, and clouds. Click at the clapperboard icon at the top of the screen and select Add Level Sequence. Give it a unique name and click Save. This will create a sequence for the animation that you'll put together. As soon as you do this, the sequencer window will appear with its timeline and track windows. It's now time to load some models into Unreal Engine. You can use your own models for that, or you can use the project files provided with this tutorial. Go back to the Content Browser tab, right-click in the empty space, and select Import to Game to import your first asset. In this case, it will be the animated alembic cache of the dress from Clo3D. Set the import type to Geometry Cache in the Options dialog. Leave everything else at the default and import. This will take a while as my dress animation is quite long. Once the dress alembic has been imported, click and drag it from the content browser into the 3D viewport. Rotate it if needed so that it's standing upright. This can happen as the up axis of Clo3D and Maya happen to be different than that of Unreal, but it's no big problem as we can easily change that in the Import-Export dialogs or just simply rotate the model as soon as it's in Unreal. If you click play at the top of the screen, you can preview the animation in context as the game is running in the main viewport. Try to move around and see what it looks like from different angles. Notice that the back of the dress's surface is not rendered as the material is currently one-sided. We'll change that, of course. Go over to the Sequencer tab. Click on Track and select Actor to Sequencer and then the dress alembic. This will create a new track in the sequencer. Then, if you click on the plus button in the track, you can select Geometry Cache, and this will let you play the dress animation in the sequencer. This is different to playing the animation in the game, as we're using Unreal as a renderer in this case and not as a game engine. This means that what will eventually render to a movie is not what we see when we play the game, but what we see when we play the timeline. Click on the cube with the plus icon at the top of the screen, which lets you add objects to your scene quickly. Select Cinematic and Scene Camera Actor. This will add a cinematic camera to your scene and give you a preview of the new camera as an inset in your view. In the main view, you can see the camera object. Press W on the keyboard and move the camera so that it frames the dress. You can move it one axis at a time, which makes it a little easier. However, the dress is a little out of focus. So with the camera actor selected in the outline, type Focus in the search, and under the focus settings, change the focus method to tracking. To set the actor to track, use the object picker to pick the dress in the viewport. This will bring the dress into focus, adjusting the field of view of the camera automatically. Time to import the rest of the models. Go to the File menu and select Import into Level. I use OBJ most of the time as it's supported by both Clo and Maya, and it gives me consistent results, although you can use any mesh format that is accepted by Unreal. Drag and drop the avatar from the content browser anywhere in the view, select the dress and reset the search to see the transform options in the properties. Right-click next to location and select Copy to get the dress's location, select the avatar, right-click next to location, and select Paste to give the avatar the location of the dress. Do the same for the rotation by selecting the dress, right-clicking next to rotation and selecting Copy, then selecting the avatar, right-clicking next to rotation and selecting Paste. Now the avatar is exactly at the same position in the view as the dress. Next, right-click and select Import to Game and import the jacket as a static mesh. Again, drag it into the view and repeat the process copying location or rotation from either the dress or the avatar to the jacket. Everything is in place now, so we can test our animation. Go back to the Sequencer tab and in the corner of the main viewport, click on Perspective to change the view to the cinematic camera called Cine Camera Actor by default. You can go back to the perspective view at any time by clicking the Eject button next to the pilot actor name. You can also create a folder for your textures where you can put all of the textures imported from Substance Painter. Right-click inside your textures folder and import the textures you've just exported from Painter. It's important to remember that Unreal requires the Virtual Textures option be on in order to work with multiple UV tiles per mesh. To turn that on, you have to go to Edit Project Settings and type Virtual in the search field. Then turn on Enable Virtual Texture Support, Virtual Texture on Texture Import, and Virtual Textures for Opacity Mask. Importing all files may take a minute due to their higher resolution. Once the maps are imported into Unreal, double-click on the color textures. We'll change the compression settings to improve texture quality. For the color map, select BC7. Here, you can also verify the alpha channel. Let's check the normal map. Unreal Engine usually recognizes normal maps and automatically sets their compression settings. If this hasn't happened, select Normal Map in the compression settings. Set the packed texture compression setting to Masks No sRGB, as it consists of 3 grayscale maps. You can verify the maps here by turning the channels on and off. To create a new material, right-click in the content browser, select Material and name it Dress. Then double-click it to open it in the Material Editor. In the Material Editor, select the cloth shading model, find your textures for the dress, drag them into the editor and line them up. The cloth shader allows us to use the fuzz attribute, which helps create a fabric look. Let's connect the maps to the corresponding inputs: color map to base color, normal map to normal, and the third packed map. This contains 3 individual maps in its channels, and we need to connect them as follows: red to ambient occlusion, green to roughness, and blue to metallic. Also change the blend mode to masked, so we can use an opacity mask. And connect the color nodes alpha to the opacity mask. Have a look at the individual red, green, and blue components of the packed texture. We're going to use one of them for the cloth input in the shader. This controls the amount of fuzz on the fabric. It turns out the roughness map on the green component works best for this. This will give us fuzz only on the non-metallic areas of the fabric. By pressing 1 on the keyboard and left-clicking, you can create a grayscale value of 0.5, that's a mid-gray, for the cloth's fuzz color. You may also want to experiment with other colors here. Next, place a multiply node by holding M on the keyboard and clicking in a blank space to multiply the red output of the packed texture and adjust the ambient occlusion. Before closing the material editor, make sure to make the material two-sided. Save the material and drag it onto the dress in the viewport. Change the rendering method to path tracing for an in-context preview and then save everything. This completes setting up the dress in Unreal Engine. Thanks for watching. In the next video, we'll export and apply the maps for the jacket.